Okay, this to me it looks like an integration by parts question. Okay, so I say that because I mean you always think about integration by substitution first, and if you let this be u or let that be u, you don't get the other one. So the real only choice is to let u equal to integration by parts. Let's let u equal to the inverse tangent because we don't know how to integrate that. Or we do, but it's another integration by parts. So let's keep it simple. dv will be then x dx. And we get 1 over 1 plus x squared for du. And v is equal to half of x squared. Okay, so then this whole thing can be expressed as a half x squared minus half of x squared 1 plus x squared. Okay, so this can be, so actually let's first do the long division. So this is the same thing as x squared plus 1 minus 1. I'm going to split it like this. Okay. So I just added 1 and subtracted 1, and that will turn into a 1. And we have this. Okay, so yeah, we don't need partial fraction for this. This is just the antiderivative of arctan. Okay, but it gets confusing, you know, when you're doing partial fractions and you're in the mind of I'm going to do partial fractions, right? Then you know you might get tricked to doing partial fractions, right? But this is just simple arctan, so it's going to be plus half of arctangent or tangent inverse of x, okay, plus constant. So I made a copy and paste error. Copy and paste, which I do a lot. Okay, so that's the final answer, right? We can't combine it because this one is x squared and this has no x.